everyone. So today we will be discussing Unit 1, that is Introduction to Statistics. So let us start. So in this unit, we will be covering the following topics, which is Introduction to Statistics, Meaning of Statistics, Role of Statistics in Research, Limitations and Misinterpretations of Statistics, Scales of Measurement, and Descriptive and Inferential Statistics. So what is the meaning of statistics? So statistics can be described as a branch or subfield of mathematics that mainly deals with the organization as well as analysis and interpretation of a group of numbers. So statistic mainly deals with analysis and interpretation. In simple terms, statistics can be described as the science of classifying, organizing, and analyzing data. Okay, so this is the basic meaning of statistics. Let us study some of the basic concepts in statistics. So we'll start with population. What is population? This term can be used to describe the persons, objects, elements, animals, or even reactions that display a pattern of characteristics that is unique. It can also be explained as a set of persons, objects, elements, animals, reactions that the researcher wants to study. If a researcher wants to carry out a study on adolescents in New Delhi, then his or her population will be all the adolescents in New Delhi. So this is an example that if a researcher wants to study something about the adolescents in New Delhi, then the population will be all the adolescents in New Delhi. What is a sample? A sample, in simple terms, is a group of individuals who participate in the research. Okay, so if we take the example of adolescents in New Delhi, as we discussed above or we discussed it previously, it is not feasible for the researcher to contact and collect data from all the adolescents in New Delhi. So it is not possible for the researcher to contact each and every adolescent in New Delhi to collect data. Then what the researcher will do? The researcher will take a sample, which will be the representative from that population, and he or she will study that sample. Okay, so for sampling, there are several sampling techniques available. Let us study what are those sampling techniques. So it is important that a sample is representative of the population. What do you mean that it is representative of the population? That is, it is as much as possible similar to the population or possesses the same characteristics or elements as the population. Okay, so it should possess the same characteristic or elements of the population. Okay, the sampling techniques are relevant in research which will help in the selection of sample. So there are several sampling techniques which are available in research which help in the selection of sample. Okay, so this is the little bit introduction about sampling techniques. There are different types of sampling techniques. We will just know the names of them and will not go into the details. Probably we will go into the details as and when we progress through the course. Okay, so there are different types of sampling techniques such as probability sampling, non-probability sampling. Then there is a simple random sampling, which is the most popular type of sampling techniques used in statistics. And there is a convenient sampling. Then there is a systematic random sampling. There's a voluntary sampling. Then there's a stratified random sampling, judgmental sampling, cluster sampling, quota sampling, multi-stage random sampling, snowball sampling, and so on. So these are some of the main type of sampling techniques used in statistics. Now, what is a parameter? A parameter can be termed as a value that provides information about the population that is investigated in the research. So what does a parameter do? It provides information about the population about which the researcher is trying to study. Okay, it can be described as a measure of the population and refers to the indices of central value. So what does parameter refers to? It refers to indices of central value, or it could be dispersion, it could be correlation, and so on, of all the individuals in the population. So this is the important word here, of all the individuals in the population. For example, if a researcher wants to know mean weight of newly born infants in India in a given year, this can be termed as a parameter. Why it will be termed as a parameter? Because it describes the weight of all newly born infants in India in a given year. So it describes the weight of all newly born infants. So it will constitute a parameter. An exact parameter is not always easy to obtain, and any parameter will have a statistic. So obtaining the parameter is not always easy because, as I discussed, we cannot contact each and every member of the population. Okay, so what do? We take a statistic and we study that statistic. Okay, so what is a statistic? As aspects of the population are measured by a parameter, in a similar way, aspects of a sampling are measured by a statistic. So parameter is an aspect of the population, whereas statistic is an aspect of the sample. Thus, the researcher will measure the weight of, say, 500 newly born infants. Okay, so that will be a sample representing all the newly born infants in a given year and work out a mean weight. Okay, so this mean weight can be termed as a statistic. So this is an example of a statistic. Okay, variables. Variable means something that varies or that changes. It can also be explained as quantity or a number that will vary or will have different values. Okay, so these are variables. Now, these are the symbols of parameter and statistic. Okay, so these are the mean, the standard deviation, and the variance. If it is population mean, then it is represented by mu. Okay, if it is the sample mean, it will be represented by x bar. Okay, similarly, standard deviation is represented by sigma in case of population and small s in case of sample. Variance is represented as sigma square in case of population and s square in terms of sample. So now let us discuss the type of variables. The first type of variable is the independent variable or the IV. Okay, what is an independent variable? A variable that is manipulated by the researcher is the independent variable. For example, in a study on effect of light on performance of individuals, a researcher can manipulate light to be bright, dim, or normal. So in this case, light can be an example of an independent variable. Okay, now what is a dependent variable or a DV? So in a research, variable that is measured for any changes when independent variable is manipulated is the dependent variable. For example, in the above example, performance is an example of the dependent variable. Now, what are extraneous variables? Variables that may impede or interfere in the relationship between independent variable and the dependent variable is called the extraneous variable. So, example of this variable is, in the above example, noise can interfere in relationship between independent variable and dependent variable, and it is possible that changes in dependent variable, that is performance, is due to the extraneous variable, that is noise, rather than independent variable, that is light. So this is the extraneous variable. Now, what is a quantitative variable? This is the variable that is numerically represented. For example, like intelligent quotient, IQ, weight, height. So these are represented in the form of numbers. What is a qualitative variable? A qualitative variable has measurable characteristics that are not numerical but categorical. For example, like gender, like male and female. Gender can be male or female. Socioeconomic status can be high or low. Or religion. So it can be Christian or Muslim or Hindu, etc. So these are the qualitative variables in which there are categories. What is a continuous variable? A continuous variable is the one which can have any value and is continuous in nature. For example, weight is suppose 56.98 kgs, age is 2 years, 5 months, etc. Okay, what is a discrete or a discontinuous or a discrete variable? So this is a set of integers that is distinct. Okay, for example, like the number of children, number of two-wheelers, etc. So that is a discrete variable, okay, or a distinct variable which will consist of a set of integers. Now we will study what is the role of statistics in research. Okay, so statistics plays an important role during various stages of research. For instance, while drawing a sample from a population for research, statistics can be adequately used. Sample size for a research can be determined with the help of statistics. Certain formula can be used to compute the sample size. Further, in test development, statistics can be used in order to ascertain the reliability and validity of the test. So, statistics plays very important role in research, whether you have to draw a sample or you have to study some characteristics of the population, okay, or you have to determine the reliability or the validity of the test. So, in this case, statistics plays an important role. Okay, techniques like factor analysis can be used effectively for reduction of data. That also finds application in development of psychological tests. Normal distribution can be used in the development of norms. Okay, so there are techniques like factor analysis which can be used for the variable reduction, and normal distribution, which we will study later, can be used in the development of norms. Thus, statistics plays a very important role in the test development process. So now we will study the components of a research. Now, what is the main component of research? That is the problem. Okay, what is the problem? So, problem can be described as the general objective of the study. Thus, if a researcher wants to study relationship between perceived parental behavior and self-concept of adolescents, then the statement of the problem will be to study the relationship between perceived parental behavior and self-concept of adolescents. So this will be the statement of the problem. The statement of the problem provides information about the general focus of the study. Okay, so this is what a problem is. Now, what is a hypothesis? So based on the statement of the problem, the hypothesis can be formulated. Okay, so these are the tentative statements that are tested with the help of scientific research. A hypothesis can be a null hypothesis or an alternative hypothesis. Okay, so this is a hypothesis. What is a sample? Any study is carried out on a sample, because I told you that accessing each and every member of the population is not possible. So a researcher takes a sample and studies that sample. The nature and size of the sample will depend upon the nature and purpose of the study. Also, based on the requirement of the study, either probability or non-probability sampling techniques are used to derive the sample. So based on the objective of the study, the researcher will use either the probability sampling techniques or the non-probability sampling techniques. Now, what is a research design? Any research will also have a research design that provides information about the outline and structure of the research. Research design is important in order to not only solution to the research problem, but also to control any variance. Okay, thus research design can be explained as a means to allow researcher to seek answers to research problem in an objective, valid and accurate manner, keeping in mind the economical aspect. Okay, now what is collection of data? The next component of research is collection of data. So data can be collected with the help of standardized psychological tests, interview methods, observation questionnaires, and so on. So whatever method you want, you can use that to collect the data depending upon your problem. Okay, various methods can be used to collect data from the sample based on the objective of the study. Okay, now what is data analysis? So once the data collection process is over, the data can then be subjected to data analysis, and that analysis can be qualitative also and quantitative also. It can be both. Okay, conclusions and generalization. Based on the results obtained in data analysis, conclusions are drawn, and then the researcher is in position to generalize the results to the population. Okay, so this is about the conclusions and generalization. Now let us discuss the limitations and misinterpretation of statistics. So some of the limitations and misinterpretation of statistics are as follows. First is, statistics cannot be used with a single observation. To compute statistic, we need a group of data or observation. So you cannot work in statistics with just a single observation. You need to have a group of data. For just a single observation, statistics cannot be applied. Second, events or phenomena that are qualitative in nature cannot be subjected to statistics. This is a kind of misinterpretation of statistics. Statistic is applicable to events and phenomena that can be measured in terms of numbers. So this is a misinterpretation of statistics. Then third is, inferences based on statistics cannot be exact, as the inferences that are drawn are based on mathematical laws. Statistical laws are based on majority of observations and may not be applicable to each and every individual. So statistical law may not be applicable to each and every individual. In order to adequately interpret the results of statistics, knowledge about statistics is required, especially with regard to when to use what technique and how to interpret the results obtained. Okay, so you need to have the knowledge of statistics. If you do not have the knowledge of statistics, then you cannot make out which techniques you have to use and how to interpret your results. Okay, now statistics also has no control over the data collection process. The result obtained will provide no indication of any dishonesty or bias in the data collection. Okay, so whatever the results you will obtain, so that will not indicate if you have done any dishonesty or bias in data collection. Therefore, so it is prone to misuse and much depends in this regard on the researcher rather than the statistics. So researcher has to be responsible enough to ensure that there is no dishonesty or bias in the data collection. Otherwise, the results can be misinterpreted. Now, statistics may not provide a complete picture about a certain phenomenon or event. There are a number of factors that can have impact on a certain phenomenon, but statistics will be able to measure only those factors that are quantitatively expressed. So whatever factors you are including in your analysis, okay, you can draw inference based on those factors only. So those factors, some factors which are not included, cannot say anything about them. Okay, so it does not provide a complete picture. Okay, now the results obtained are also prone to be misinterpreted, especially by untrained person who lack knowledge about statistical techniques. Okay, their computation and interpretation. So the people who do not have knowledge about statistics, they may misinterpret the data. Okay, or they may wrongly interpret the results. And the last is there is a possibility of errors in statistical decisions. So these are some of the limitations and misinterpretation of statistics. Now we will discuss the scales of measurement. Okay, first is the nominal scale. Nominal scale can be used to measure variables that are qualitative as well as exclusive in nature. For example, gender, religion, and so on. The term nominal is derived from Latin term nominalis that relates to name. For example, with regard to gender, males can be assigned the number 1 and females can be assigned the number 2 or vice versa. So this is about nominal scale. Then coming to ordinal scale. Ordinal scale means an order. Ordinal scale involves ranks, that is, the data can be assigned ranks based on whether they are less or more, low or high, bad or good, and so on. The data is thus ranked in the terms of its magnitude. The term ordinal is derived from the Latin term ordinalis, which indicates order. For example, based on the performance of students in mathematics, they can be ranked. Thus, a student who secures first rank has performed better than a student who has secured second rank. And a student who has secured 10th rank has performed much lower when compared to the student with the first and the second ranks. So this is the ordinal scale. Coming to the interval scale. Interval scale is the most commonly used to measure psychological variables. These scales are similar to the ordinal scale as the categories can be ranked and are exclusive as well. But the degree of difference between two participants is same. For example, the degree of difference between individuals obtaining a score of 22 and another individual obtaining a score of 23 is same as that of an individual obtaining a score of 34 and another individual obtaining a score of 35. In interval scale, there is no absolute zero. For example, there cannot be a person with zero attitude. Okay. Now, interval scale can be subject to mathematical calculations. So this is about the interval scale. Now, ratio scale. Ratio scale has all the properties of all the scales, nominal, ordinal, and interval. Besides, it also has an absolute zero that indicate presence or absence of certain property or characteristics. Ratio scale displays equidistance between the adjacent categories. For instance, the difference between 1 kilogram of wheat and 2 kilograms of wheat and difference between 5 kilograms of wheat and 6 kilograms of wheat is same. Okay, so difference between 1 kg of wheat and 2 kg of wheat and the difference between 5 kg of wheat and 6 kg of wheat is same. Further, 10 kilograms of wheat is half of 20 kilograms of wheat. Also, 0 kilograms indicates no wheat. Okay, so various mathematical calculations can be carried out with the help of ratio scale. So this is all about ratio scale. Now, let us see the properties and examples of the scale of measurement. So these are the certain properties. Some of these properties will be present in all of the scales, and some of the properties will be present in some of the scales. Okay. So, for example, categories are exclusive in nominal, ordinal, interval, and ratio scale. Okay. Categories can be arranged in an order in ordinal scale, interval scale, and ratio scale. Equidistance between the adjacent categories can be obtained in interval scale and ratio scale. Real zero is present in the ratio scale. Examples are roll number assigned to students, ranks obtained by students in psychology class test, scores obtained by the individuals on an attitude scale, errors made by the individuals on a memory test. So these are some of the examples of properties and examples of the scale of measurements. So now we will discuss the descriptive and inferential statistics. Descriptive statistics mainly comprises of description and organization of the data. It can be termed as a technique that helps in summarization of prominent characteristics of a distribution. Based on the properties of the sample, the descriptive statistics can be categorized into the following. Okay, so first is the statistics of location. It covers techniques like measures of central tendency, including mean, median, and mode, frequency distribution, percentiles, and so on. We will be discussing each of these statistics of location detail in the next units. Now, what is statistics of dispersion? So this covers techniques related to measures of dispersion, including quartile deviation, standard deviation, range, average deviation, and variance. Again, we will be studying each of these as we move along the course. Statistics of correlation includes coefficient of correlation like Pearson product moment correlation, Spearman's rank order correlation, and Kendall's rank correlation. Correlation mainly helps us to understand the relationship between the variables. Okay, so we will be studying correlation as we move along the course in the next chapters. Okay, now what is inferential statistics? In inferential statistics, inferences are drawn about the population based on a representative sample. As stated by Veeraraghavan and Shetgovekar, inferential statistics refers to the mathematical methods based on probability theory and helps in reasoning and inferring the characteristic feature of the sample drawn from the larger population. So in inferential statistics, you mainly make inferences about the population based on the sample. Inferential statistics can also be effectively used to make estimations and predictions. Okay. So basically, there are two types of procedures under inferential statistics, which are estimation and hypothesis testing. What is estimation? So estimating probability of a phenomenon is known as estimation, as given by Veeraraghavan and Shetgovekar in 2016. As we know from the explanation of inferential statistics, that inferences are drawn from the sample that is representative of a population, and these inferences can then be generalized to the whole population. Okay, so what you do here, you draw inferences from the sample, okay, and that sample is the representative of the whole population, and then you draw inferences about the whole population. In these inferences, the researcher will make an estimation that needs to be close to the actual or true population value. Okay, so whatever estimate you will get, that should be close to the actual or true population value. So this is about estimation. So there are basically two types of estimation, point estimation and interval estimation. Okay, in point estimation, you estimate a single point. Okay, so this is a type of estimation in which the value is a single point. For example, the estimation for sample mean is made as 46.8. Suppose this is the estimation for sample mean that is expected to be equal to the population mean. Point estimate comprises of sample mean and sample proportion. The population mean is mu. Suppose the population mean is mu, the sample mean will be x bar. This is how it is denoted, the population mean and the sample mean. In a similar manner, the population proportion is capital P, then the sample proportion will be small p. Okay, so this is how representation is made. What is interval estimation? An interval estimate is an interval or two numbers within which the population parameter could lie. Okay, so it is an interval in which the population parameter could lie. Thus, for population mean mu, the interval estimate will be x lies between A and B. Okay, the interval estimate is greater than but lesser than B. So it is greater than A but less than B. The interval estimate is greater than A but less than B. It will lie somewhere between these two points A and B. For example, an interval estimate could be 45-47, within which it is expected that the population mean will lie. So it is expected that the population mean will lie within this interval. As the researcher has an interval, she is able to trust that estimate is close to the population value. So if the researcher has an interval estimate, then he can make an idea or he can trust that the true estimate is close to the population value. Okay, so the population value will lie somewhere in this interval. Okay, so this is about interval estimation. Now coming to hypothesis testing. Hypothesis is a tentative statement that is investigated during the process of research. Hypothesis pertains to certain phenomena and is based on a theory. Data is then collected by the researcher in order to validate the hypothesis. Thus, the hypothesis is rejected or accepted by a researcher based on the results obtained. Hypothesis testing is also referred to as a process involving statistical decision making with regard to population value that is based on the sample value. Okay, so this definition was given by Veera Raghavan and Shetgovkar, 2016, page 9. Though while drawing inferences, one needs to ensure that the hypothesis is not incorrectly accepted or rejected due to the results that are influenced by chance factors or confounding factors. Okay, so this is the introduction about hypothesis testing. Okay, there are several steps in hypothesis testing. We will discuss that also. So basically, hypothesis testing is a tentative statement that is made in the process of research. It is a sort of claim. Okay, now you have to validate that claim, whether that claim is true or not. Okay. So let us discuss the types of hypothesis. The first hypothesis is the null hypothesis. Null hypothesis is also referred as hypothesis of no difference or as null hypothesis, and it implies that there is no difference between the two groups. Okay, so suppose there are two groups, then the null hypothesis will state that there is no difference between the two groups. For example, if a researcher wants to study if there is significant difference in job satisfaction of government and private bank employees, she will formulate a null hypothesis. And what will be the null hypothesis? That there is no significant difference in job satisfaction of public and private bank employees. Okay, and then based on the results obtained, the hypothesis will be rejected or accepted. So this is the null hypothesis. What is the alternative hypothesis? So alternative hypothesis can be termed as counter proposition to null hypothesis. It means that the alternative hypothesis is the opposite of null hypothesis. Okay, it is formulated by researcher based on theory. The hypothesis states that there is significant difference between the two groups. So this hypothesis will state that there is significant difference between the two groups. For example, the researcher can formulate the alternative hypothesis as there will be a significant difference in job satisfaction of public and private bank employees. Okay, so this is also a neutral alternative hypothesis that does not provide any direction and thus is termed as non-directional hypothesis. Alternative hypothesis can also be directional. Okay, so directional and non-directional means, non-directional means if the alternative hypothesis is in the form of not equal to. Okay, and if the alternative hypothesis is in the form of greater than or less than, then it will be a directional hypothesis. For example, public bank employee have higher or lower, higher means greater than or lower means less than, job satisfaction when compared with private bank employees. Okay, such hypotheses are formulated based on the review of literature. Okay, so this is about the alternative hypothesis. So basically there are two hypotheses, null hypothesis and the alternative hypothesis, which are the opposite of each other. Now, what are the steps in hypothesis testing? First step is null hypothesis or alternative hypothesis needs to be formulated by the researcher. Then in the second step, a level of significance is selected. Okay, this level of significance could be either 0.05 level or 0.01 level. The term significance in the context of statistics implies probably true. Okay, that indicates that results are free from chance factor at a specified level of significance. What does term significance indicate? That probably true means that the results are free from chance factor. For example, if there exists a significant difference in job satisfaction of public and private bank employees, then the researcher could either be 95% confident, that means the level of significance will be 0.05 in this case, and p-value will be strictly less than 0.05, or the researcher can be 99% confident, which means the level of significance will be 0.01 and p-value will be strictly less than 0.01. So he can be either 95% or 99% confident about the results obtained. P-value here stands for probability value. Okay, now these were the two steps. Now there are two types of errors which are usually committed in hypothesis testing. So these errors are known as type 1 error and type 2 error. Type 1 and type 2 errors. So in this process of hypothesis testing, there are two errors which could occur. So let us see what are these two types of errors. Okay, now there are two scenarios. Either null hypothesis is true or null hypothesis is false. Okay, now suppose the null hypothesis is true and you reject the null hypothesis, then you are committing type 1 error. Okay, and if the null hypothesis is false and you are rejecting the null hypothesis, then the decision is correct and you are not committing any error. Okay, now if the null hypothesis is true and you are accepting the null hypothesis, again you are not committing any error and your decision is correct. Okay, and if null hypothesis is false and you are accepting the null hypothesis, it means you are committing an error, and that error is known as type 2 error. So basically there are two types of error, type 1 error and type 2 error. Okay, now what is step 3 in hypothesis testing? So we have discussed step 1 and step 2 and the type of errors. So step 3 is based on the parameters specified in the null hypothesis, a statistic is calculated. A sample is taken by the researcher and data is collected. Statistic that is thus obtained from the sample is then used in order to make an estimation about the population parameters. Then the third step involves calculating a statistic which is calculated based on the sample. Okay, so that statistic which is obtained from the sample is used to make an estimation about the population parameters. Then step 4 is decision is made whether to accept or reject the null hypothesis. Okay, in this regard, the p-value or probability level is selected. Okay, that was discussed under step 2, and accordingly decision is taken by the researcher. So once you obtain the statistic, okay, based on the p-value, you have to make a decision whether you have to accept or you have to reject the null hypothesis. Okay, so this was all about unit 1. So we have covered different concepts in unit 1. We started with introduction of statistics. We discussed what is the definition and meaning of statistics. Then we discussed what is the role of statistics in psychological research, what importance the statistics have in psychological research. Then we also discussed what are the limitations and misinterpretation of statistics. Okay, what are some of the limitations? That if one of the limitations was, for example, that a person should have statistical knowledge to interpret the results of statistics. So all such limitations and misinterpretations were discussed. Then we discussed scales of measurement. That was the nominal scale of measurement, ordinal scale, ratio scale of measurement, interval scale of measurement. So we discussed all these scales of measurement. And then we discussed what is descriptive and inferential statistics. So this was all about unit 1. Okay. So these are some of the practice questions. You please try out these questions. Okay, some of the questions are from the previous year exam paper also, previous years. So the first question is define statistics and discuss the basic concepts in statistics. The second question is describe the scales of measurement with suitable examples. The third is elucidate descriptive statistics. Means elucidate means elaborate or describe the descriptive statistics. Okay, so this was all about unit 1. I hope you found unit 1 interesting. Okay, thank you so much. Thank you all so much. Okay, bye for now.